Here we've got a question where we've got to work out the total pressure. And this is a question which could very easily be asked and has been on previous exams. So you've been told this time the number of moles of each gas at equilibrium. So there's no need here to do a Rice table because you've been given the equilibrium moles already. We need to work out the total pressure in this equilibrium mixture. First thing I'm going to do is going to write down the Kp expression for this particular reaction. So it's the partial pressure of NO squared, partial pressure of oxygen, and that's all divided by the partial pressure of NO2 squared. Now remember that it's very important to remember that partial pressure that's equal to mole fraction times total pressure. And it's the total pressure that we want to find out. Okay, so we want to work out the total pressure. Okay, the first thing we need to do is we need to work out what this mole fraction would be. Now, the mole fraction, I'm going to start with, say, NO. It's going to be equal to the moles of NO over the total moles. And that's equal to then, now we've already been given these moles equilibrium, 0.04. And that's divided by, when we add up the three different moles values, which is here we add these three numbers up, we get 1.02. When we do that calculation, we end up with 0.0392. And what we do again is we repeat this for the other components in the equilibrium mixture. So let's work out the mole fraction now of oxygen. Again, it's just the same method. And this time we've got moles of oxygen is 0.02, so I need to change that to a 2. And that gives me 0.0196. And then we repeat the same sort of procedure for the mole fraction of NO2. And that is 0.96. And that gives me a mole fraction of 0.9412. Again, these mole fractions here should all add up to give 1, which when you check, they do. Now, we've been told what the Kp is. It's 6.8. I'll just highlight it. The Kp there is 6.8 times 10 to the minus 6. So we can say then 6.8 times 10 to the minus 6 is equal to then partial pressure of NO squared, partial pressure of oxygen, divided by the partial pressure of NO2 squared. Now, obviously we haven't got the partial pressures, but we have got the mole fractions. So what we need to do then is we need to call this total pressure here, which is what, we need to call this total pressure here X. And if we call that, let that equal X, then we can set up the following. So we can say then 6.80 times 10 to the minus 6 then is equal to, well, the mole fraction of NO is 0.0392. And obviously we want the partial pressure, which is this mole fraction here, times the total pressure. We can call that total pressure now X. And we need to square that, times by the partial pressure of oxygen, which again is mole fraction, times the total pressure, which I'm calling X. So that's 0.0196 X divided by the partial pressure of NO2, which is mole fraction, times total pressure, which is 0.9412 times the total pressure, and again squared. And that, in effect, now is a maths problem where we need to solve for X. So I'm just going to copy this, and then we'll solve for X. The first thing that you need to do is we need to cancel the X's. So what we can do is we can cancel one of these X's with one of these X's. Okay, and that just gives this 1x here now on its own. Okay, so when we do that, this should simplify to the following. So we can get rid of this x and get rid of this x. Let's just join this a little bit closer. So we've now got the following calculation. Now, my advice would be is to multiply these, get these square terms and multiply them. So that would give you, once we do this, that would give you 6.80 times 10 to the minus 6 is equal to, well, this is when we do this calculation of 0.0392 squared, you end up with 1.534 times 10 to the minus 3 times 0.0196x divided by, and when you do 0.09412 squared, you get 0.8859. And then we need to solve that for x. So if I want x on its own, this will come up there, and these numbers here will go down below. So what we end up with is 6.80 times 10 to the minus 6. That's going to be then multiplied by 0.8859 divided by, and I'm just going to cut these actually, all these numbers down here. And that then is equal to my x value. And when you do that calculation, then x should equal 0.200 atmospheres. So you do need to be ready for calculating these total pressures. I've tried to show you the real step-by-step process there, and it's just a case of practicing these until you are familiar with the technique.